Hello, everyone. Welcome to Etteplan Cybersecurity webinar. It's a privilege to have you here online with us. And today our topic will be Secure Development Lifecycle. Boy, do we have a program for you. We have 3 speakers for you today. And the first speaker of today will be Donnie Werner with thoughts of a hacker. Donnie will be followed by Tommy Pund, who will talk with you guys about secure development lifecycle. And I will wrap up today's session by explaining what's happening on the regulatory front, how secure development lifecycle is becoming a regulatory requirement. So here we have the speakers for today, and as you can see, there's also a possibility to post questions in the chat. So please write any of your questions and we'll address those in the end of the last presentation. So there will be a questions and answer session. And as the first speaker, please let me introduce you to Donnie. Donnie will start by telling a bit about himself and then go into his thoughts about being a hacker. Thank you, Donnie. Stage is yours.
Thank you, Antti. My name is Donnie Werner. I'm a cybersecurity expert here at Etteplan. I've currently been with us not quite a year yet. My most recent background was with the Finnish global mobile company, not Nokia, doing global penetration testing and vulnerability assessment. Prior to that, basically freelance, discovering exploits and vulnerabilities. And yes, I was a bit of a hacker. And I find myself now in the profession that I am in this genre, the cybersecurity, and enjoy to sometimes reflect back on why I enjoy what I do and why I've had success in doing what I have. And it always amazed me early on, and when I first started to do this, because it was simply a hobby. And I began to find vulnerabilities in products and softwares. And myself, I'm not a developer, I'm not a programmer. And I was trying to understand that why was I able to find these things when people were being paid, developers being paid lots of money to be able to write things and so on and so forth. And so it gave me a little bit of a drive to try to understand why I was able to find out. And it took a long time, but I started to realize a few things. And I guess one of the first things that I came to realize is that in almost every case that I was having luck and succeeding in, it seemed that there was something wrong basically at the foundational level of the product or thing that I was looking at, so to speak. It always seemed that there was some type of gap there that was allowing me in, and I really tried to think a lot more, try to get into the mind, and that's what I would like to kind of take you guys today, is kind of into my mind of things of where and how they go. Because, for example, I wanted to explore how does this relate, how do things relate, how can I connect between the real world and the cyber world? And I saw this photo on the internet, and it really struck home to me in a way. Well, of course, this isn't related to computers, but we have basically in this picture like a fully developed building that is basically fallen over, and it's fallen over at the base or the foundation level of the structure, and I thought that this was quite an interesting perspective in a way. And even the investigating team, so to speak, was like, how does even the basic kind of builder make this type of flaw? And I really connected with that in like some of the things. What am I finding that I think to myself, this flaw shouldn't exist. These people should be understanding in their development and so on and so forth. And I'm going to lead you there a little bit as we go. And in preparing this, I also ran across this interesting picture. It's funny at first, I admit. There's this tree growing through the middle of a house. But I really started to think about many different things. Number one is safety or security of this. And I also wanted to think about what came first? Was the tree first? Was the house first? Did the tree grow and then they had to cut a hole in the house? Well, I don't know, but in looking at this and kind of giving an evaluation, a threat model, kind of a risk of going on, what happens when the wind blows, for example? Because the gap here between the tree and the structure of the home is, it's only a few centimeters. And I'm thinking that, well, it's a palm tree. It's maybe this is in Florida, for example, in the United States. They have a lot of hurricanes there. Wind blows a lot. And this could possibly cause a lot of damage. So I'm trying to get into thinking about what's going on here, basically. And normally I speak to developers. I have a very varied audience today, I believe. So I want to try to keep things simple, but I want to go through and just show some quick examples of what I've seen as I've been looking at things in my position and trying to understand further about not only the flaw, but what's going on in the development mind, what's going on as a team level, so to speak. And I'm just going to jump right on in here. This isn't too technical for you to follow along, I hope. But this was a simple login mechanism that was on a device, and it was actually written in Java. I don't know Java programming very well. I know a little bit, but not very well. Certainly, I can't write a full program. But anyway, I test things in what we call a black box way, which means I don't have any information about what's going on other than what is before me, what I've been told about the product. In this case, I was not giving any usernames or passwords, for example. I want to evaluate the product as kind of from that nasty side, that hacker side, the offensive security side, so to speak. So anyway, I tried this login combination, as you might, of admin as the username and admin as the password. And I got a very interesting error response back. It said, user ID not found. And I thought, okay, if the user ID wasn't found, oops, excuse me, if the user ID was not found, then it must maybe mean that the username admin is not found. Here it says the login password is incorrect. So I wanted to try again and see what would happen. And I tried again, and I tried to log in as foo and foo. And it told me here the user ID is not found, and the one previous said the login password was incorrect. So I knew that I had correctly guessed the username of admin, likely. I wanted to see what was going on. How is this happening? And technically, it's not too hard to see after we apply a quick tool and kind of look at the communication. In this case, me talking to the server, so to speak, is in pink, and the server's response back to me is in blue. I've sent a simple request saying that I've sent this username and password. The server has sent a few items, and then at the very bottom, I notice here it says admin, comma, admin 0. And well, that's exactly the password that I tried, and the username that I tried was admin and admin 0, and I was granted access into this application. And that was amazing enough in itself. And then I tried to understand, well, how did this flaw happen? Did the person, did the group not have an understanding of how to write a mechanism to do a login in this language? Were they not finished yet and needed to maybe show the project manager that, yeah, the login is working and that they will fix it at a later time? I really don't know, but I do know one thing. I do know that there's some gap somewhere along the lines and within the development process that has led to this type of flaw. And so this gets me thinking in many ways is, why am I having success in doing these things? You know, as a project team, as a development unit, I understand that there's project goals, you have development goals, and you want to make sure that, you know, you fast forward into production, your proof of concepts, you have your features lined up, all your components and everything else. You need to go to market, um, we need to create features. These are the things that we often hear from inside the development team. Oh, we have a robust API. Hey, we've got some security management going on and threat intelligence, all these fancy buzzwords. Oh, we're using some secure framework, and hey, we're hosted on a big secure cloud, so everything is really great. And again, I want to show you just a quick example of sometimes how even a false sense of security and overconfidence can lead to a problem. Again, kind of a gap. So this big secure cloud, and I was tasked again in this kind of black box style of trying to violate the security posture, and I was able to do so. And in this case, we can see that actually I've obtained root administrative privileges on a database cluster on this big cloud, and I have done that through the browser actually. So through a flaw and actually some configuration, that the base application of this product was really solid, and this particular piece of the application was a demo app by the same group, but by having a gap and not fully understanding kind of the third-party products and frameworks that they are working with, a configuration flaw opened up the avenue for me to be able to compromise this system in a very critical way. And again, this makes me think about where's the gap? Why were they so good in one aspect and not in another? And I think it comes to kind of this holistic or broad approach. And what we're going to get down is that you need to have a process that kind of covers all the areas that you're dealing with regards to not only having a successful project, but also the security. And that's more and more important every day. I understand this. You say, hey, we're agile. This is the big buzzword that we're fast and we're agile. We have continuous integration, continuous development. Is security a part of that? Is my first question always. What are you doing with regards to security? Are you just kind of running the testing tools and reacting to output? Well, I say, well, what about the security updates for maybe your base operating system, for the libraries that are used in your product? What about the third-party products and frameworks that you're using, so on and so forth? Are those up to date? Do those have known vulnerabilities? Are the developers that are coding and working with those environments, do they understand not only how to successfully program and deploy, but do that in a secure manner as well? For example, what are you doing about code review? Is this something that your development team, for example, is taking on? Maybe even more important is, who's the security responsible for your product or project? Do you have one? Having a security responsible and a single point of contact is a very, very important part of the whole, so to speak, in my opinion. Well, what about your infrastructure, your architecture, segregation, hosting? Have you thought of these things? Have you done what we might call risk and threat modeling assessments to understand what is the surface area that you're exposing? What are the issues maybe with people who are going to be administrating your product and running your product and using your product and have access to your product? Whether that be application, big cloud, mobile app, maybe a dashboard in an automobile, maybe some type of medical device. We don't know, but we want to approach those from kind of the same area, in my opinion. To go back a little bit about who I am, I'm American by birth and grew up on the West Coast in California. But I've lived here now in Finland for more than 10 years. But when I was younger, in America, we had these very interesting commercials on television. And well, cars isn't really talking about security and computers, but it made me think when I started to understand a lot of the issues that surround security and development. And was that in these advertisements, it was quite funny that the car would drive off the cliff and roll off the cliff and crash at the bottom, and then it would drive off and everybody would be safe. And this was really, really funny. And I really didn't reflect on this until later when I ran across this advertisement. And I believe this is from the 70s or early 80s, this Volvo ad. And when I ran across it, I thought, isn't that a funny way to advertise a car? To show it being smashed up. That's a really strange way to sell a car. Usually you want to show how great, how beautiful it is and how wonderful it looks. And then something caught my eye in this advertisement quite a bit. Sure, we have the car is crashing here, but I also noticed the Volvo crash test results, for example, are there. And I thought back what I do. Now, I kind of crash things. I try to break in and violate the product that I'm testing, and I write a report. And then I see here they have the framework of the car. Yeah, the body, the main structure of the car, what keeps it solid, what keeps people safe inside, what makes it secure. I started to look at this even more, and it occurred to me that what they're actually doing is a bit of a safety life cycle development is what they've got going on. Sure, they're smashing the car. They're feeding it into some test report. They're passing that report on to the engineers who are taking the recommendations and considerations in there to make changes. And they're crashing the car again. They're making a report. They're making changes and they're crashing the car again. What Volvo realized was that in this green area here, they realized that if you could keep this from being crushed or being deformed, so to speak, in a impact, that the survivability rating of the people inside was greatly enhanced by an extremely great margin. And even today, this is the process that automobiles use, and must also pass that this part of the car does not deform so that it can't come in and hurt you or to kill you. But this safety development life cycle, security development life cycle, was exactly the way that we start to see things from this point of view, to start to understand where are the flaws, where are our gaps, and security development life cycle is what we call that, and it places security as an integral part of the product or application development process. For example, starting from the requirements of the design, to coding, to testing, security development lifecycle is building security into the product or application at every step of the development process from the foundation level up. So SDL in a nutshell, basically, it's quite simple to understand. On one side, we have the training, and we're just going to kind of use that can underlay everything, that wherever your competency gaps are laying, that training can come into play, of course. Then we have this, the execute, the response, basically, kind of if something really bad goes wrong. But we want to focus mostly on these kind of the requirements. For example, you want to make sure that the beginning of your project that you establish your security requirements, that you're understanding your security and privacy risks. Maybe you have an assessment towards that. Forward those into considerations on your design, and you're establishing your design requirements. You want to make sure at that point that once you have a solid architecture, you're understanding the workflows. You can then start to analyze the attack surface. How is this being used? What is exposed? So I want to do some threat modeling right on from there. During the implementation and doing this, use the approved tools, for example, in doing development work. And if you're coding or whatnot, make sure you're not using old functions that have been supplanted by new ones, for example, like using sfprint instead of fprint is in the old C. That would be a good time to maybe perform some static analysis on your code base, for example. All these different types of things that we can apply some tools to do some analysis. and onto verification, kind of after the product has reached a particular maturity level. Then they go ahead and do actual hardcore analysis, maybe some dynamic analysis, maybe some type of, maybe doing some fuzz testing, a little bit of security review at that point. On to release. This is where we release the product. This is where we hopefully are making money in the development. But we also want to make sure that we're prepared if things go wrong. Do you have an incident response plan, for example? Have there been any kind of final security review by an unbiased third party, so to speak, at this point in time? In software development and most of the developments these days, we understand that kind of how things are flowing here. For planning, implementation, testing, evaluation, you have some new needs, new features, whatever. Well, you feed those in, and so on and so forth as the product continues and matures. Well, security, adding security into this is not any different. And often I hear, oh, the security guy is coming and he's going to giving us so much work, extra work, and this and that. And this is not how we should be thinking. Of course, we should try to understand that we all want the best from the software. We want the best from our team and the best for development. And this security development life cycle is, in my opinion, one of the best ways to start to achieve that, because it covers so many different areas. From security by design, we want to understand things to have like a minimal attack surface. You want to have the least amount that people can, quote, kind of touch, is the way I like to put it, of course. Make sure that when something goes wrong, you have some secure defaults so that things are basically more difficult to begin with. Maybe consider whitelisting is a good idea. We want to have things like, user segregation, duty segregation, ideas of least privilege, for example, on that. We want to have a defense in depth. We want to make sure that we're covering all the areas. And even when we fail, we want to make sure that we fail security. In the quick example that I showed with the login procedure, that was failing in a very insecure manner, is that it gave feedback to an attacker, for example, myself in this case, that if I entered the correct username, it would tell me that the password was wrong. And that if I entered in an incorrect username, it would tell me that I've entered into a incorrect username. So I was able to, just by process of elimination, to be able to determine what types of users were available on that system. Once I have a valid user, then it becomes much easier to brute force maybe the password for that. Oh, excuse me there. We don't want to blindly trust services. For example, that as the other example that I showed for the cloud, that they had a big secure cloud that they were hosted on. They felt very comfortable. But again, I was able to find a way through a configuration error on their behalf to be able to fully compromise the position that they had there. And really, to be honest, the more simple that you keep security, the better it is, the more easy it is to manage as well, the better it is to implement. We want to avoid security by obscurity. We want to fix issues correctly. I always, when I'm working with the development unit, for example, if we're running an SDL session, if I'm doing a penetration test or vulnerability assessment, I always like to say, hey, let's ask, let's think, let's consider. Would you feel confident to use the application that you're designing, for example? Would you feel comfortable to allow your mother to use it, or your husband, or your children? What about your children's children? Things that we design now are setting the foundations for the future, so to speak. We want to make sure those are very strong. Can you always trust the user? Many cases you get into these evaluations, the threat modeling, risk assessment portions, for example, and find that their development is over trusting the users, allowing them to have too much power, or privileges, this ideas of least privilege. Just a quick story from my past, long time ago in my early career. I was actually interested in joining a website, and website had your kind of standard login, username, password, a little bit like what we saw, but this had a slightly different kind of a flaw in that if you put in a known username, you could type a very special characters into the password field and would log in as that user. This was a flaw mostly in the technology of the website that was being deployed, but also in the coding itself. I wanted to join this website. I really liked it. I don't recall what it was about. Maybe it was about cars or something, but I was really interested. But I saw this flaw and decided, well, I don't feel too comfortable in giving my information to join this site. But I did, however, try to contact the owner of the website, and I was successful in doing so. I actually was able to track down his phone number and everything, and I gave him a call because he hadn't replied to my emails, and I got the guy on the phone, and I explained what had happened, and I said to him, you know, I can log in as any one of your users, and anybody else can do this. And he said to me something very interesting. He said, I understand what you're saying, but you're not one of my users. And one of my users would never do that. Again, I said, well, yeah, I understand I'm not one of your users, but I was able to log in with this flaw. He kept repeating back to me, yes, but you're not one of my users. And he seemed to be kind of stuck in this mindset. And eventually I just had to say, thank you, sir. Have a nice day. But when I started to be now where I am in my career and to do these evaluations, this story really stuck with me a lot. Can we always trust our users? Well, not only can you not trust your own users, but you can't trust those who are not your users as well. So that's just a little bit of a story that I like to tell from my past, and it's very close to me, actually. I use this in my mind all the time. And I think that's where I'm trying to get everybody from my talk, is to understand kind of a different way of thinking. You should ask yourself, is the code that you're writing proper and secure? Maybe you're jumping into a new area and don't feel confident, but you're going to try anyway. Maybe that's what happened to the person who was writing that login procedure that I showcased earlier. Maybe they were very well versed in one language, but when it came time to jump into another language, maybe they weren't as confident, but they just went ahead and did it anyway. We don't know ultimately about that case of what the underlying issue was, but we do know that there was a gap somewhere in the process there. And this comes to the next point that I'd like to make, is that ask yourself, do you understand the security concerns and the proper implementation and deployment in a secure way of the third-party frameworks that you're using to develop with, to deploy, so on and so forth? These are questions that you should ask yourself if you're a coder, developer, maybe as a team leader as well. What I'd like to say is let's try harder, and we should always be trying harder and secure. One thing that we found kind of doing these evaluations, and in my experience, we found that people do not want to communicate security concerns as much as they would normal types of things going on within the development. Often it's in a debriefing after I've done an assessment and I've found serious issues, where a developer or maybe an architect will say to me, yeah, we know about that. Why hasn't it been fixed? And invariably, that problem is how I severely have violated the security posture of their product, gained administrative access or complete control over their product or website or some other way to violate the security posture there. I've seen it time and time again. Adding security features will not fix bad planning, will not fix the foundation. Adding some features quickly is not going to keep the building from falling over because the soil was bad. It was actually a bad choice in the foundation of where they would put the building, for example. Secure development must be integrated into what the team is already doing as well. I often, we know that understanding and accepting some new framework or regulations, so on and so forth, is often very, very difficult. But that's one thing where in the upcoming slides and talks that this is very easy to be able to slip into your current development process is this SDL, Security Development Lifecycle, and understand how that's going to benefit in every aspect in a continuous integration and development environment, for example. I want to point to some quick resources about this SDL before I continue. OWASP is a kind of open web vulnerability consortium. They have great guidelines of security by design principles. Microsoft has a wonderful outline and framework directly regarding the security development lifecycle. For example, SANS is another great resource. They have an excellent white paper on DevOps or secure development operations. Carnegie Mellon University, for example, has continuous integration in DevOps. So a lot of these concepts are available to explore and to understand. They don't offer full solutions. That is what we're putting together, is being able to slipstream these into your process, particularly after a risk assessment or threat modeling exercise, or even a vulnerability assessment and penetration test. Synopsys also has something, a really great paper also called the Agile Security Manifesto, for example. Say, okay, well, what can we do? You want to ask, and I think that this is a great question. This always kind of comes up. What can you do? And I think this is what I enjoy. Well, if you're a project leader, maybe you're architect, some other, very responsible. Do it right the first time. Build a solid foundation into your product. Delegate the proper talent that you have. Don't throw people into the deep end in a new aspect, so to speak. Maybe keep your talent on top of what they know best. Stick with that. Incorporate this secure development lifecycle concepts from the project's foundations, from the beginning and planning. And even if you're reaching now a mature stage that we're able to come in and evaluate your product, your operations, your development, and understand where we can start to fit in these concepts to help build this secure development lifecycle program that will benefit. Maybe you're a developer, maybe you're a coder. I like to say that the best thing you can do is realize your own knowledge gaps. The old saying goes, if you're an alcoholic, you have to understand that you're an alcoholic first before you can get treatment. This is the old saying. But I think it's actually quite relevant that we often don't understand our own flaws until we start to look inside and to start to understand ourselves as well. Do research. Consider what you're doing. Try to take a different approach. Of course, we want you to use secure coding and development practices. But more important, like I outlined earlier, is if you're a developer coder, your employer, your project leaders, whatever, they've invested a lot of money and time into you, and they want you to grow with the company. At least I hope so. So inquire about training opportunities, maybe some workshops, maybe some books. Maybe you want to reach into that new area, and that's probably a good thing also. But make sure you have the support, not only for yourself and your own confidence, but also that of your employer as well. I think it's very, very, very important. I keep hitting this the wrong button. There we go. let's do it right the first time, is what I like to say. Again, we want this building a strong foundation. Learn from your past mistakes. Everybody makes mistakes. Not only as people, but in projects or whatever, we all learn and then we grow. We learn and we grow. We learn by failure. That's how people learn, is by failing. And we want to make sure that when we do fail, we don't fail in a disastrous way, of course, but we want to understand and learn from that and understand where are those gaps. Yeah? Include security in your continuous integration and continuous development efforts. Apply some of the concepts that you'll be hearing actually from Tony coming up. Apply these SDL and defense in depth concepts, methodologies, the best practices frameworks. Develop effective security testing based on your needs. Use latest in secure development concepts. And we're also able to help when we do that, when we are doing a threat modeling, we're doing a risk analysis, penetration test, vulnerability assessment, and understanding from the results of those and from the input from those to be able to understand how is the SDL fitting in to what's going on with that particular entity. Where can we find the strengths along those lines, but also the weaknesses there, and then start to build and fill in on those. Again, just some of the resources, of course, as I mentioned, OWASP, Google, Synopsys, for example, Carnegie Mellon, SANS. Google's also a great help, believe it or not, and there's nothing wrong with that. Yeah, let's do it right the first time, and let's not mess up the future. And, I want to thank you for taking the time to listen, number one, and hopefully that some of what I've said has made you or helped you think in a little bit different way. And from there, I will conclude my current presentation and get ready to hand it back over to Antti to introduce our next speaker.
Thank you, Donnie, very much for your presentation. Our next speaker will be Tommy Pund. Please, the stage is yours. So, Tommy, could you please introduce yourself to the audience a bit? What's your background?
Yeah, my name is Tommy Pund. I'm working here at Etteplan and in testing and cyber security. I'm not a hacker as Donnie, but I got my security mindset from working at the airport for 13 years, where doing a mistake could jeopardize, for example, lives. But yeah, on the SDL, setting a designated time for defining project requirements allows development teams to consider how to best integrate security and privacy into the development process and identify key security objectives. The need to consider security and privacy upfront is a fundamental aspect of the SDL, and the optimal point to define requirements for a project is during the initial planning stages. Identify and assign the security advisor who will be your team's point of contact for security support and additional resources. There should be minimum security requirements for the application as it is designed to run its planned operational environment. Specify and deploy a security vulnerability tracking system that will allow you, for example, assign and track completion of security-related bugs and tasks. Quality gates and bug bars are used to establish minimum acceptable levels of security and privacy quality. Defining these improves the understanding of risks associated with security issues. Yeah. And for last, security and privacy risk assessments are mandatory processes that identify functional aspects of the software that require deep review. Proper design practices identifies the overall requirements and structure for the software and establishes the best design practices. And it's perhaps the most important thing on the SDL. Design specifications should describe security or privacy features that will be directly exposed to users, such as those that require user authentication to access specific data before use of a high-risk privacy feature. Those should also describe how to securely implement all functionality provided by a given feature. Satisfy the minimal cryptographic design requirements established for your product when you establish security requirements. And complete a security design requirement. During the implementation practice, the development team mandates and enforces best practices to be followed for the duration of the project. Development teams should define and publish a list of approved tools and their associated security checks. It would be also good to use the latest version of approved tools to take advantage of new security analysis functionality and protections. Project teams should analyze all functions that will be used together with a software development project and deny those that are not safe. Static analysis of source code provides scalable ability for security code review and can help ensure that secure coding practices are being followed. Though by itself, static review is generally insufficient to replace manual code review. Verification is the point at which the software is functionally complete and is tested against security and privacy goals outlined in previous phases. And this should be already in line in early proof of concept testing. Runtime verification is necessary to ensure that a program's functionality works as designed. Desired level of security test coverage should be achieved by using different techniques, such as fuzz testing. It's common for an application to deviate significantly from the functional and design specs created during previous project phases. So it's critical to check again threat models and attack surface when it's code complete. In preparation for releasing a product, the project team must create the incident response plan, perform the final security review, and archive all relevant data for post-release servicing of the software. Every software release subject to the requirements of the SDL must include an incident response plan. Even programs with no known problems at the time of release can be subject to new threats that emerge over time. Final security review is an examination of all security activities performed on a software application prior to release. And all relevant information and data must be archived to allow for post-release servicing of the software. And in last presentation, you saw a palm tree and a fallen building, but why Mount Everest? Well, if you go there, would you go unprepared or alone? This doesn't like me. Yeah. because probably you get into an accident or worse well before reaching the top. SDL is like Sherpas helping and guiding you to get to your goal. Of course, there is always a risk of something going wrong, and it has, speaking about reaching the Everest with Sherpas or developing securely even with the SDL. Yeah, I can't promise that, for example, your software will be secure using the SDL, but it's the routine that reduces the risk of things going down and learn from the mistakes. And after your SDL is done, what's next? You do it again. Once you start using the SDL, you'll probably see if there's a lack of competence in security. So if there's a need for security training, or just to stay informed about security basics and recent trends in security and privacy, then basic security training should cover basic concepts such as secure design, secure coding, secure testing, threat modeling, and privacy. SDL is really all about reducing the risk of making the one critical mistake that could compromise a product or a company. Thank you.
Thank you, Tommy, very much. One of the first steps in security development lifecycle is the threat modeling, and you guys been often involved in threat modeling also. So how do the designers feel when they for the first time participate in a threat modeling?
Well, it really depends on a project, but normally first pretty confident, and in the end, well, a little bit scared.
Very
good. Do you, Donnie, have anything to add to that?
No, I would say this scared kind of comes into play, but what we noticed that when you start to work and develop, especially in this kind of threat modeling and risk assessment, is that you start to understand the gaps there. And what we're able to do, and what we've noticed working with this SDL, is that we're able to directly map these gaps into these areas of the SDL, so that we continue to have a plan, and while we're going along with the plan, be able to make sure that we capture these gaps, we fill them in, and make the line smooth, for example. I think is one of the most important things that we've realized in doing this, and is providing, in my opinion, really the best benefit that you can hope to be achieving, and are able to start basically at anywhere along your product or development maturity process. Yeah.
Very good. Thank you, Donnie. Hey, thanks, Tommy, also very much for your presentation, and I will then continue with my part. So I will give you, in the end of our webinar, I will now give you an overview of kind of what's happened in the regulatory parts of Europe and USA. And what I can now see, I started following up this regulatory changing, especially embedded security, about in 2019 when the EU Cybersecurity Act had just been launched, and in 2020, let's say in 2020 there was some certification schemes that were published from the EU Cybersecurity Act, but during this year there has been really a load of different European regulation and also activities on the US side that look like cybersecurity will become a regulatory requirement for in device development, also many areas of software development. And this is because there are safety and privacy risks, and these are caused by connectivity. There's artificial intelligence and autonomous robotics, and these new technologies have not really been taken into consideration in the today effective legislation. So I will present you the most important regulations that you might want to follow yourself. And what you should keep in mind that when you see the kind of types of requirements that are made, the secure development lifecycle, security development lifecycle is a feasible approach for meeting these new regulatory security requirements. And to start with, what maybe in EU and US, an important concept is critical infrastructure. And you might have heard about the Network and Information Security Directive 2 proposal, the new NIS2 proposal, where the scope of critical infrastructure has been significantly enlarged. There's the essential entities that authorities should in member states monitor proactively, and the important entities that the authorities should then follow up if there's any cybersecurity incidents. And what you guys should know is that according to NIS2 Article 18, member states should put in technical and organizational measures that would be necessary for both the essential and important entities when they acquire information systems, develop them and maintain. So this sort of implies to the fact that secure development lifecycle could be a requirement that is put forward on the national legislation also. Finland is often leading these kind of regulatory efforts in Europe, and the Finnish Ministry of Telecommunications has stated that they aim at implementing supply chain requirements for essential and important entities by end of next year, and they will also select which individual essential entities, which companies need to become ISO 27001 certified by 25. So what you also should know that this area called manufacturing under the important entities, this actually contains all the manufacturers of electrical equipment, all devices, machinery. And when we look at the scope of critical infrastructure, there's also plenty of global regulatory activities ongoing. Maybe the most important one right now has been that in new automotive type approval, cybersecurity engineering is a regulatory requirement. The automotive manufacturers need to have a cybersecurity management system in place and also follow a secure development lifecycle. And these requirements are rolling down the whole supply chain down to tier 1, 2, and 3. So if you work in the automotive sector, secure development lifecycle is something that you cannot avoid in the near future. Also medical devices, which are both split here in EU under healthcare and manufacturing. So there's also FDA is gonna next year really put out a new pre-market guidance for cybersecurity, and they're recommending a couple of good cybersecurity standards for SDL. Then in Europe, there are 3 very interesting regulations, actually 4. The 4th is artificial intelligence regulation, but from a safety perspective, I will discuss 3. The first one is general product safety regulation that is replacing the general product safety directive from about 20 years ago. And what they have noticed, there's plenty of new technologies out there, connectivity and such. And now in this regulation, they are stating that all products that are sold in EU should be safe, and they should also kind of contain the appropriate cybersecurity features that are necessary to protect the product against external influences, including malicious third parties, when such an influence might have an impact on the safety of the product. And there are no other kind of standards yet for this. So actually the only way to kind of meet in product development these requirements in the future is to apply a secure development life cycle or secure product development life cycle. It's a practical way to start with the threat modelings and create evidence that you comply with this requirement. What should also be known here is that this also impacts any software development that is used on devices that might then in the end have safety impact. So any modifications of products from software hardware perspective that make them kind of unsafe will make that this modifier will carry the legal manufacturer responsibilities. And it's also good to note that there are similar kind of fines planned for this general product safety regulation than in GDPR. And this, what you should also know is that I'm just waiting for the EU to implement this kind of regulation, and there's only a 6-month transition period. I will later on talk about radio equipment and delegated acts, and also machinery regulation. So in end of October, EU adopted these delegated acts for let's say cybersecurity related to radio equipment. And depending on the use case, for all radio equipment, there will be a requirement they are not able to harm the network or is functioning, or they cannot misuse network resource. This means that any IoT devices, any devices with radios you put on the market, they need to be adequately protected so that they cannot degrade the services of the network where they're connected. Then if the device manages any personal data related to privacy or so it needs to ensure protection of the user and the subscriber, and if it's used for payments, then there needs to be protection for fraud. And now there's been a lot of discussion in the European Standardization Organization of what technical standards will be used, what will the technical requirements be that will be objectively tested by accredited test labs, and they have evaluated IEC 6244342, industrial control systems, technical requirements, also the consumer IoT standard, and notice that neither of these totally fit the wide range of different IoT devices, radio devices out there. So they are now starting standardization work. It will probably be a series of standards, and hopefully they will be available sometime in 23, because regardless of the availability of any harmonized standards, the delegated regulation will come into force. And this, of course, places right now quite a big risk to any product development projects that they involve devices with radios, and it would be a good idea to take into use secure product development lifecycle and any applicable technical industry security standards that are related to the use case in order to create the sufficient evidence of compliance. Then we have also the machinery regulation proposal. So they have clear essential health and safety requirements that are related to cybersecurity, connecting machinery devices to others if they are under machinery regulation. They cannot lead to hazardous situations. Then all the safety critical hardware, software, and data needs to be adequately protected against intentional corruptions, and also there needs to be evidence collection of any legal and illegal interventions. And also there needs to be in control system a certain level of robustness against the attacks from malicious third parties. And here also no harmonized standards right now, just clear essential health and safety requirements, and secure product development lifecycle is again a very practical way to demonstrate compliance. You have to also notice that all software that runs safety functions are under the machine regulation as high-risk machineries, and also artificial intelligence systems. So something to look into also. In the US, there's an executive order on improving nation's cybersecurity, and there's a lot of activities ongoing for making secure development lifecycle a mandatory requirement for any IT systems that the federal government purchases, and they are also striving to make any consumer IoT and consumer software providers to disclose that is a secure development lifecycle used in the development, and what kind of security functionalities have been implemented. And this is a very ambitious timeline that they have, and this is also something very good to follow up. So I hope that you have enjoyed the session today, and you've learned about the importance of security development lifecycle and its contents. And at Etteplan, we can help to get started. So typically, secure development can be added on to development projects, to a product lifecycle as a modular process. So actually, adding additional tasks to the development lifecycle, starting from the very beginning. So we can help you in planning how to get your team trained, helping in identifying the applicable security regulation standards, and then starting with the threat modeling to understand the different safety and privacy risks, categorizing those, and defining what kind of security requirements are needed to mitigate those risks that you see that need to be mitigated. We can help you in defining and writing a good security implementation specification that shows how all the technical security requirements have been implemented and how all these applicable standards and requirements are met. We can help you in developing guidelines for development, hardening, testing. We can help you in automating the vulnerability management of third-party software components, and of course, what Donnie and Tommy are also very efficient is security testing, planning it, doing it, and reporting it. And also Etteplan has good capabilities in supporting you in quality management system development and developing a secure development life cycle. So that's pretty much it that we had today. Let's see if there's any questions in the chat. Just a second. If you have any, I think we can stay here online. If you have any specific questions for us based on the presentations, please write them in the chat, and we'll wait for a couple of minutes if there's anything. Otherwise, we would like to thank you for your participation. And if you have any questions, don't hesitate to call us or contact us, and we'll be happy to answer your questions and support you. So I don't see any questions here at all. So in that case, I think that we will wrap up the session. Thank you, audience. Thank you, Donnie. Thank you, Tommy, for your very interesting presentation. And I wish everybody a very good afternoon and a good week. Stay safe and secure.